Now that we're able to pick a feature to split on, we need to decide what to do next, how to recurse, and when to decide to stop. So our goal now has gone beyond just learning a decision stump or just that first level decision tree or picking that first feature to split on, and learning a whole decision tree from data. So if you look at our decision stump that we learned splitting on credit, if you look at that first split where credit was excellent, we see that every single data point in there was a safe loan. So there's nothing else to do. There's no reason to recurse or trying more. We just make that what's called a leaf node, because all other splits will also be predicted as safe. But for the other two, for the cases where credit was fair or the cases where credit was poor, we need to look at the subset of the data that has fair credit and the subset of data that has poor credit and build the next decision stump from each one of these, and then from there build the next decision stumps and so on. So in our example, if we were to keep going, build the next decision stump for the data that is fair, where credit was fair, we will see that the results will be something like this. I would split on term next. That would be the next best thing to do. And then if we look at the data that has poor credit, we'll figure out the next best thing there is to split on income. And for the points with low income, everything was risky, so we stopped splitting from there. So credit poor, income low, everything is risky, no need to build a decision stump. But for the other case, where the credit was poor, the income was high, we see there's some risky points, some safe points, we build another decision stump from there. And then if you were to do that, we'd learn something like this, which completes our entire data, our entire decision tree. So we see now that we have branches that take us to leaves in every possible split. So what we've described here is what's called a recursive algorithm. It starts with a process where we pick the best feature split on, then we split our data into a decision stump with this selected feature, and then for each leaf of the decision stump or each node associated with it, we go back and learn a new decision stump. And the question is, we keep iterating like this forever, or do we stop somewhere? So what are the criteria to stop recursing is the question here. And the criteria are extremely simple. So the first criteria we've already seen. For the nodes I've selected here, including that first node where credit was excellent, every single node is associated with data points of just one category or one class, or same output. So for excellent there, everything was safe. And for the case where the credit was fair, but the term was 3 years, everything was risky. So as we can see, for those, there's no point in keep on splitting. So the first stopping condition is stop splitting when all the data agrees on the value of y. There's nothing to do there. And there's a second criteria, which is only happened over here, where we stop splitting and we still have some data points with safe and risky loans inside of that node. However, we had used up all of the features in our data set. We only have 3 features here: credit, income, and term. And on that branch of the decision tree, we used all of them up. There's nothing else to split on. We get the same things if we kept splitting on forever. And so the 2 stopping criteria are extremely simple. Stop if every data point agrees, or stop if you run out of features. So if we go back now to our greedy algorithm for learning decision trees, we see that step 2, you just pick the feature that minimizes the classification error as we discussed. And then we have these 2 stopping conditions here that we just described, 2 extremely simple ones. And then we just recurse and keep going until those stopping conditions are reached. Either we use all the features, use them up, or all the data points agree on the value of y.